Now we have to move on to the second stage in the string design, which is the material selection. This implies understanding the behavior of such pipes in corrosive environments where CO2 and H2S could be present in the produced fluids under the effect of pressure, temperature, pH, among others. The MR0175 ISO 15156 standard from NACE, which is the National Association of Corrosion Engineers, describes the general principles and gives the requirements and recommendations for the selection and qualification of metallic materials for service and equipment used in oil and gas production. It is divided into three parts. Part 1 refers to all the mechanisms of cracking that can be caused by H2S. Part 2 refers to carbon and low alloyed steels, and Part 3 refers to corrosion-resistant alloyed steels. Depending on the severity of the environment with respect to the sulfide stress cracking, which considers the pH and partial pressure of H2S present in the production fluids, 4 regions are established. The aggressiveness increases when the pH is lower and the partial pressure of the H2S is higher. Region 0 represents non-sour corrosions. Hence, normally no precautions are required for the selection of steels used under these conditions. Region 1 represents the mild sour service, where minor or inexpensive precautions are required. Region 2 shows the intermediate sour service, and precautions should be increased. And finally, Region 3 represents severe sour service, and important precautions are mandatory. The standard also specifies which grades are already qualified for different environments and the minimum service temperature that they could withstand. In general terms, we can say that when CO2 and H2S are present and the partial pressure of CO2 and H2S increases, the material suitable for such conditions moves from the standard API grades to high corrosion-resistant alloys with a high content of nickel and chromium.